Zoom in a little bit. Okay, that's good. All right. So, by the way, I'm recording now. The way I'm going to give you this problem on the quiz is the following. So, first problem of the quiz, do it by graphing. Problem number 2 on your quiz will be something that looks very close to this, but I'm going to give it to you kind of different. I'm going to say f of x equals x squared plus 9x. Almost the same, kind of different. Same, but different. All right. Or y equals x squared plus 9x. Doesn't matter. It depends. When you see the x and y axis, do you see them in terms of x and y? When you get to higher level mathematics, y is going to be like disappearing more and more. X and f of x. It depends. Okay? Doesn't matter. As long as you know that my solutions are on this axis here. My solutions are here. There'll be like a point here and a point out here, or 2 points here, or just 1 point, or not at all. Okay? Okay? So I'm going to give you the quiz in this format where there's green over here. I'm going to say, here's the instructions that you'll literally see. Find the solutions by factoring is what the instructions will say. So it'll be very clear to you what you have to do. Okay? And now we got a factor. What type of factoring am I doing here? Nope. No. What'd you say? What was the second thing you said? Greatest common factor. Okay? Why? Because there's two terms, so you might be thinking difference of squares because there's two terms. But is there a difference sign in between the two terms?
Yeah.
No. Difference means minus. There's no minus sign between them. So it's greatest common factor. If there's two terms and there's a plus, it's GCF. Should I write that down for you?
Wait, if there's a plus, then only one of them has a plus?
No, an addition sign between them. Yeah, you're taking the sum of two terms. Two terms, and there's a plus between them. I'm going to go to GCF. If there's, GCF can be applied for more than that, but just to kind of keep you focused on the quiz, if there's two terms and a plus between them, it's GCF. Okay? So what's the greatest common class? I'm going to stand up for this real quick. We should all be thinking about the answer, so can we get 100% mental focus on this problem for a second? What's the greatest common factor of x squared and 9x? Guys, if you said it already, I heard you. It's not that.
Is it x?
Thank you, Quinn. It's x. All right. So I go y equals x. Oops, let's do it this way. X times the quantity. What's left? X and a positive 9. X plus 9. Okay. So now I factored it. But how does factoring give me solutions x-intercepts? Well, remember, x-intercepts has a y value of 0. So I'm going to make my y into a 0 equals x times x plus 9. Which is kind of what they're implying up here. Equals 0. Okay, so now there's something in math called the zero product rule. Okay, there's no need to make it complex. If this quantity here is 0, well, how can you get 0 when you're multiplying things? The only way you get 0 when you're multiplying two things is if what? One of them has to be 0, which means either this is equal to 0 or that is equal to 0. So I'm going to do both actually. I'm going to do x equals 0 and x plus 9 equals 0. And that's how I find my two solutions here. But I have to solve for x. Well, this one's already solved for x, so I know one of my solutions is 0, 0. And for this one, I have to subtract 9 from both sides. So x equals -9, so -9, 0. and those are my two solutions. And that's how you do it with factoring.
On the sheet though, it said just factor, right? Or is like you have to find the solution?
No, it says solve each equation. So solve meaning find the solutions, meaning they want that.
You can't put like FOIL and just parentheses and then another parentheses and x plus 3 and x plus 3.
Wait, FOIL? X plus 3, x plus 3. But if you multiply x plus 3 times x plus... Yeah, what you're talking about is like that's like the C factoring method. We will do that type of factoring. X plus 3. You know when you would get x plus 3, x plus 3? If it was x squared plus 6x plus 9 factors into x plus 3, x plus 3. But this was just x squared plus 9x, so not the same. Yeah, okay. Okay, let's do another one. Should I try to find one that's AC factoring for you? Wait, what type of, let me just ask you, what type of factoring for number 2? Number 3?
Same one, same thing.
No, difference of squares this time. How do you know? There's a minus sign here. And the second thing is, the first one has to be a perfect square, and the second one has to be a perfect square. Can you take the square root of x squared perfectly? What's the square root of x squared? X. So I know x and x is going to be my first term in both. What's the square root of 4? So 2 and 2 go here and here. Put a plus sign, put a minus sign, there you go. You're done.
Wait, and they have to be perfect squares for which one?
Both have to be perfect squares.
Just leave the answer like that.
For the difference of squares method. This is called difference of squares.
And for difference of squares, you just leave the answer like that for the...
No, you have to complete the process and say x plus 2 equals 0 and x minus 2 equals 0. Because you got to find the solutions.
Are all the solutions just 0?
Well, the solutions are where y is equal to 0, which is why I'm setting y equal to 0. So that I could find where it crosses my x-axis.
It's just going to be plus 2 or minus 2?
Yeah, x equals negative 2, x equals 2, which means negative 2 comma 0 and 2 comma 0. I go from here to here, and from here to here.
That's not going to be on the quiz, sir.
No, it will be on the quiz.
You said that the one on the quiz would be AC.
Oh, yeah, sorry. So this type of question, but it could be AC specifically. I mean, I want you guys to be prepared for everything, because on the test you'll get probably one of each.
So plus is GC and minus is
We should have 2
difference of
factors
squares.
questions.
No.
On the quiz?
Yeah.
Sure, Quinn.
No.
Why do you want to be hated by the class? Why?
Wait.
It's like you're on purpose trying to do that. Dude.
You have practice.
Okay, let's do it. Okay, so we did one GCF. We did one, so far, difference of squares. Let's do one C factoring, and then we'll go to the hardest one. Okay, so this is just C factoring. Okay, how do you know? 3 terms here. 3 terms.
Are you writing without even looking?
Yeah.
How do you do that?
I know what I'm writing because my hand is moving.
Oh.
Like
Why
my.
don't you just look at that?
Well, I'm not gonna. What am I gonna see here? It's black. It's all black.
It's blank?
There's nothing on this.
What? So how do you know where to write?
My cursor moves as I just have to bring my thing close to it, and then I can see my cursor moving, and then I just have to touch to write. So my cursor's right now hovering over.
There's a skill, man.
Just a skill, I guess. I don't know.
That's cool.
Yeah, that is
It's
good.
got to be a talent.
All right. So 3 terms. 3 terms is either AC factoring or C factoring. But just look, is there an A value here? No.
What kind of factoring did we just do?
We did, well, the one right before this, we did, this is difference of squares.
Yeah.
This one was GCF. Did I not write GCF here? GCF. Okay. So now we're AC factoring. So for C factoring, I'm going to put the, let me grab this 21. 21 What are factors of 21 that add up to a negative 10? Negative 7 and negative 3 is correct. How do we know that? Because negative 7 times negative 3 is positive 21. And negative 7 and negative 3 give us the b value, which is why Christian, why did you pick negative 7, negative 3 to get that? To get that. Yeah, exactly. What's so funny? He answered my question. Thank you, Christian. All right. So now I'm going to take these values. Are going to go right up in here. X minus 7, x minus 3. And at least now it's fully factored. I still have to do the zero product rule. So x minus 7 equals 0 and x minus 3 equals 0. And I'm assuming you know how to solve for x here in both situations.
Do you write your final answer as like a
How?
point? Like,
You add 3 to the other side.
Add 3 to the other side, add 7 to the other side. What'd you say, Christian?
do you write your final answer as like a point on the graph, like 7, 0?
Yeah.
Yes, you do 7, 0 and 3, 0 because that shows me that you know that 7, 0 is a point on my graph and 3, 0 is a point on my graph.
But you can, and you can only do that one when there's 3 terms.
AC or C factoring and AC both for 3 terms, yeah.
How do you know the difference? Which one you need to?
If there's an A term there, meaning if there's a number in front of that, no, we should know now it's ax squared plus bx plus c. We've dealt with standard quadratics. Is there a value for where A is in front of the x squared? If it's just x squared, just do C factoring.
If it was 2x squared, then you do
AC factoring. All right, so C factoring hopefully rings a bell, and it's not too hard. I hope.
So there's 3 methods. Like,
There's 4,
four,
right?
That's 4.
The last one is going to be the one that you're going to see on your test right here. Here we go, number 7. Okay, so if you want to prepare for the quiz, hopefully you're paying like super attention right now. Okay, AC factoring. Now, why do I call it AC factoring? Because when I write the word AC next to each other, well, this also means that it's 2 variables that are multiplied, because if you don't write nothing between them, it's assumed it's multiplication. So it tells you kind of to multiply the A value and the C value.
Wait,
Right?
how do you know that it's AC factoring?
Because in the format ax squared plus bx plus c, which is your standard quadratic, you just took a test on it, your A value, if there's an A value present, AC factoring. Okay, so AC, I'm going to take A and multiply it by C, so what's 3 times negative 30? Negative 90 is right. So I want to find factors of negative 90.
Wait, can you scroll up?
I will in just a second. That add up to,
You don't need to put the X in it?
no, we're not, we don't use the X right now. Now we're just taking the numbers and trying to find, we're trying to split the middle value into 2 values. And this is the process by which I do that. Okay, so factors of negative 90 that will add up to negative 13. That when I add them equal negative 13. So what are factors of negative 90 that add up to negative 13? How would you do this, by the way, if you're not sure? You guys want to know how I would do it if I wasn't sure?
Negative 90 divided by.
Yes.
Then you go by the numbers.
John is absolutely right with that. That's a great tip. So this is what you do. You take 90, and I say, okay, can I divide 90 by 2?
Wait,
Okay.
is that negative 90 or no?
Yeah, negative 90, but I'm just trying to find the, I know I'm going to like make one of them negative. So I get 45. So 2 and 45, but that doesn't add up to negative 13 if I subtract them or add them or anything. That's not even close. Let me try 90 divided by 3. Well, that's 30. 30 and 30. So 30 and 13. 30 and 3 to get to 13 is not going to work, whether I add them or subtract them. Let me do 90 divided by 4. Nope, that's a decimal. 90 divided by 5. I got 18. Wait, 18 and 5. Hold on, let me go back to my problem now. Maybe I can use those. Maybe. So I need an 18
5 minus
and a 5, and one of them has to be negative. Oh, it does work. Yeah. So that's how I would do it. Plug in the calculator, find it that way.
Wait, one always has to be negative?
Because it's a negative 90, one of them has to be negative here.
Are both positive or they both just stay positive?
Well, if it's positive, it depends. Like, if I'm trying to add up to, let's say, like negative 23 or positive 23, what's my b value? Is b equal to negative 23 or 23? If it's negative 23, I want to do negative 18, negative 5. If it's positive 23, I want to do 18 and 5. But both of these will multiply to 90.
Okay.
Think about that for a second, absorb it, right? So if you have a positive AC value, you could make both of them negative or both of them positive. Because negative times negative is what? Positive. Okay? So let's get back on track here. I'm going to recap a little bit just so you guys can be mentally with me. A times C, we got negative 90. Factors of negative 90 that add up to a negative 13, which is my B value. Happened to be negative 18 and 5. So now I'm going to rewrite. I'm going to use a different color here. 3x squared minus 18x plus 5x minus 30. Okay? So this part and this part stayed the same, and my middle term broke apart into these two. Bless you. Okay? And now I have to factor by grouping. Okay? I taught you this process before, so hopefully this rings a bell. Here's one group. Here's my other group. Okay? Do we know what we're doing with those groups? Do we remember?
Combine,
No.
Wait, no.
That will bring us back to the original equation, which we don't want to do. Do we know what to do with those two groups? GCF. Thank you, Tyler. GCF. Okay, so class, okay, I want us all to think about this to practice our GCF skills. What's the in the purple? Look at the purple one. Hold on. Don't get ahead of me. I want everyone to think about it a little bit. All right, so there's a purpose for this. What's the greatest common factor of 3x squared and negative 18x? Think about it.
Or 6, by the way. It's 3x.
It's 3x.
Wait, between 3x squared and negative 18x?
Yeah. What can I divide? What?
Oh, yeah,
When I say what can I factor,
It will be 3x.
I'm saying what can I divide both of these by evenly?
Yeah, 3x.
Right? What's a good common denominator that can divide both by? So 3x. So I'll do this in purple.
So it would be 1 and negative 6.
So what am I left with? X minus 6. Okay, look at the green group. All right, don't say the answer out loud this time. What's the greatest common factor of 5x and negative 30? Right, think about it. The greatest common factor of a 5x and a negative 30. Okay, hopefully we all thought about it. Christian, give me the answer.
5.
5. All right, I'm going to put a positive 5 there. X minus 6. What do you know? The x minus 6, same. That's crazy, right? No, it's not crazy. That should always happen with AC factoring. That should always happen. All right, the same thing inside of underline and red. Same thing here and here. That should always happen. Otherwise, you did it wrong. But I have one more step to do. It's the rewrite, so hopefully you don't lose me on this just yet. X minus 6 is one of the parts. The other part is the outsides here and here. 3x plus 5 equals 0, and I use my zero product rule again. I'm not going to move forward just yet. Just think about what I did. Have we absorbed it mentally? Are we all with it? Has every single one of my students absorbed the information I have given you just now? You should just take the quiz now then.
No.
You guys absorbed it all you
Wait,
said.
Yes, because it's question mark.
Okay, no, we'll take it next time. But all right, let's just finish off this problem. 3x plus 5 equals 0. X minus 6 equals 0. These are two. Maybe I should write them next to each other because I have to solve both of them. X minus 6 equals 0. So I add 6 here, add 6. This one's easier. I'll just solve this one first. X equals 6. So 6 comma 0 is one of my solutions. Over here, I subtract 5. Subtract 5. 3x equals negative 5. Divide by 3. Divide by 3. So x is equal to negative 5 over 3, meaning my other solution is negative 5 over 3 comma 0. You can totally have fractions here.
Are you gonna go as well with fraction mode?
Why not?
'cause it's
So
only-
not
Yeah,
decimal.
it looks super
fraction.
hard.
Dividing negative 5 over 3 and then coming up with negative 5/3 is hard?
Yeah.
No.
What if we put it in a decimal? Or is that doing
It's so cold.
Keep it as a fraction, please. Okay, so that's AC factoring. All right, and we have like 10 more minutes.
Do you guys?
No.
Fractions.
What? What'd you say, Christian?
On this sheet though, it says all it says was factor each expression. On the. I'm not looking at a different one.
It says solve each equation by factoring.
Which sheet is that?
Well, there's two of them. There's two of them.
Why'd no one tell me? Which one did I give you guys?
You gave us a different one.
Does it say factor at all on your sheet?
It says on the back it says factor each expression.
Oh, so it has factor in.
It just doesn't say like solve it
The
on
two
the.
practice things you gave us.
That's why the other class was confused.
Yeah.
All right, but does it say factor? Find the solutions by graphing.
Oh no,
Oh, and then factor each. Yeah, factor in. Okay, so that was factoring practice. All right, well, you guys just learned the topic now, I guess, so we're fine. But thank you for that, yeah. All right, class, so, yeah, the homework I gave you involved factoring, yeah. Class? Oh, let me stop recording for a second.